Okay. So yeah, so we're hoping tonight we could be as hands-on as possible. So I see everyone has their laptops out, so that's great. Did anyone go through these steps yet to run this ingestion script? Couple folks? Okay, cool. So we just had this up here to kind of get folks set up ahead of time if you want. I'm going to go through it in a minute here, but first let me just talk about like what we're going to do here tonight and kind of what the plan is. If you want to grab the slides, graphstuff.com/zephack. And so like Adam said, tonight is going to be this context engineering challenge. Jack put together this cool sort of starter project that he'll go into a lot more detail on. But basically, what we're going to start with is like a coding agent, and we have an eval script that we're going to run. And your challenge for tonight is to improve the score of this coding agent eval by changing how we're assembling context for the agent. But we'll talk a lot more about what that is exactly, but that's the rough plan for tonight. So my name is Will. I'm a Neo4j. You're going to hear also from Jack at Zep in a bit here. Cool. So if you want to follow along, and this is going to be the focus of tonight, this links to the GitHub repo for the context engineering challenge, and there's an ingest script that, just to save us some time and set up now, might be worth just kicking off now to get started, and then that can kind of run in the background while we're chatting a bit. So if you go to this URL, I'll go ahead and walk through this now.
And just to clarify, you definitely want to run this now because the ingestion can take like 25 minutes. So that's why we're doing it at the beginning of the presentation, so you don't have to wait later. If that makes sense.
And
so you're just going to run this ingestion and then let it cook, and then we're going to talk about Neo4j and Zep, and then afterwards we'll come back to that and go into the contest. Does that all make sense? Okay. Yeah.
Cool. So this is the GitHub repo. I think the easiest way to run this is in CodeSpace. So CodeSpace is like a containerized development environment. That way you don't have to worry about installing dependencies locally. And also there's some setup scripts that run when you do that. So I think the best thing to do here is to fork a copy of this, which I have already forked. And then, let me find my fork here. So here's my fork. And if you go to code to code spaces, and then there's a big button here that says like open in code space, but I already opened it. So you'll see that here. How many people have used a code space environment before? A couple folks? Okay, so you'll see a view like this that is basically like a hosted VS Code instance, and this is a containerized development environment that's running in, I don't know, Azure somewhere, and so you have access to working in the repo, and there's some setup things that run, so that's I think probably the best way to get started here. And to run the ingestion script, step one in the README is what we just did, fork and open the repo in CodeSpace. And then we're going to want to sign up for a free Zep account. And you can sign in with GitHub or other accounts. I already created my Zep account, but then you'll be prompted to create a key. So let's call this context engineering. Cool, and we're going to take that key, and if I can find my right tab here, way too many tabs. There we go. And we're going to drop that key in the .env. There's a placeholder here already edited and dropped one in. Oops. Oh no. Where did Zep? Here's Zep. Copy this. Back to this guy. Wrong one. Way too many tabs. Okay. Cool. So that's where my Zep API key is going to go. There's also a placeholder for an OpenAI API key. We'll get to that later. You don't need that for this step. And then I'm going to run, what does it say in the README here? So the ingestion script, UV run Zep ingest. And we'll give that a run. And so what's going on here, so actually, Jack, do you want to say a little bit about what this repo is and what's going on here?
Yeah, sure. So you're ingesting a data set, which is synthetic data set of interactions between a developer and a coding agent, such as like Claude Code. So it's just these synthetic messages between the agent and the developer, like you guys. Yeah, it's being sent to Zep when you run this script, and it's creating a knowledge graph. And later on, that knowledge graph will be used to improve the personalization and reliability of the coding agent. So, but we'll get to all that. Yeah. Oh, did you have a question?
So it ran way faster than the Zep.
The script runs really fast, but then the ingestion happens asynchronously, and you can actually within the Zep web app, you can then go to the user's sidebar menu item and see the user created and then see the graph getting created continuously. But the whole thing will take like 20 to 25 minutes. Yeah. Yeah. What are anyone else's questions? What other questions? Yeah.
We ran it twice. We ingest twice.
Oh.
Or is it like?
I don't. Yeah, you might want to.
What exactly do you?
Delete the user because it might have sent the messages twice to the same user, which is not ideal. So you might want to delete the user within the Zep web app and then run the script once. Yeah. Are there any other questions? Or what other questions are there? Yes.
It says to run eval once it's done. How do we know when it's done?
Oh, you know when it's done. Well, first of all, we'll get to that in like 20-ish minutes. It'll take a while. Yeah, but if you're curious, you know when it's done because you can click the episodes page within the Zep web app and see when it's all processed.
I'll show what this looks like in Zep.
Oh yeah, that'd be great. So you've run it now, right? Okay, and that's the knowledge graph that's beginning to build. Oh wow, and now it's way larger because the ingestion is happening in the background.
And do you want to say like what these things are? Right?
Oh yeah, sure.
So this is our user, right? It's
Yes.
Fungus.
So each of these nodes are an entity that was extracted from the like chat history data. So Marcus Chen is our really very important entity. It's the developer himself. And then there's all these other entities: Jake Morrison, Query, Feat/TF. That's some kind of branch name, I guess. And then there's edges, which represent the relationships between the entities. Yeah. And if this is confusing, it's okay. We'll also, get into Neo4j, which is being used in the background here, as well as Zep. So, yeah. What other questions are there?
Cool, yeah, and I realize we just kind of like jumped in here without a lot of context, so appreciate folks just jumping in and getting set up here.
Yeah, this isn't necessarily supposed to make sense right now. We just had to do this at the beginning so you didn't have to wait later, and we'll definitely explain things more later. Yeah.
Cool.
I'll grab the mic for just a quick second.
For those who try to create feedback, did you say the button disappeared if it said it was vague?
Yes.
Is that happen for others? The submit button totally disappears? Okay, I'll come over and check it out because like I wasn't able to reproduce that.
Mine didn't disappear.
Your submit button's still there, right?
It says submit feedback, this one?
Yeah, yeah.
It's still there.
It's still there for you. Okay, so I'll come over, Nate, and I'll check out your computer. Okay, here you go.
Okay, now it's still the red.
Hmm?
Still the red. Oh, it's not, okay, it seems like it's a mobile.
Oh, yeah.
I'm gonna try to submit first.
I see on your phone. Okay, cool.
Cool. So let's talk a little bit about like graphs and like why we're using a graph here to represent the context. So first of all, when we say graph here, we're talking about this data structure. So nodes, these are the entities, relationships, connect them. And specifically in graph databases like Neo4j, which is what Zep is using under the hood, when you're ingesting those messages, that's being stored in a Neo4j database. It's using the property graph model. So nodes, these are the entities, the things. They have one or more labels that kind of group them. Think of a label as kind of like a table in a relational database, just a way to group things. And then we can store arbitrary key value pair properties on nodes and relationships, right? So this is the data model that we use with graph databases like Neo4j. And you can also, like when we saw that Zep visualization, right? We saw like an instance of that property graph. So we were essentially seeing a knowledge graph of our messages and interactions with this coding agent. So the knowledge graph, this is a term I think that is thrown around a lot, especially as it relates to AI. Knowledge graph is really good for graph RAG, right? So like when you're building AI applications, being able to find the most relevant information to ingest into the context at inference time. So context engineering, how many people have heard this term before or done any context engineering? So context engineering is really all about making sure that you have the most efficient and relevant use of your context window when you're interacting with an LLM. So on the left here, we have, I guess, like the idea of prompt engineering, right? Where we have system prompt, user message, that goes to the model and you get back some response. But oftentimes that's not enough to do the like agentic things that we want to do, or we want to ingest more relevant data that the model wasn't trained on. And so these are the things that we add into the context window to make sure that our agent has the most relevant information, or if we're talking about tools that they have access to understand and interact with their environment. But we can't just throw everything in the context window. It can't just be this like, polluted dumping zone that's not very helpful for the model either. So context engineering is really all about making sure that we have the most relevant and efficient use of our context window. If you look at like some of the things that we would put in our context are things like tool definitions, right? Tools are how the agent can interact with its environment. Maybe we have some documentation that we want to ingest, but we also have things like memory as well that we might want to ingest. So memory are things like learnings that the agent has from previous interactions with the user. So I think it's worthwhile just stating up front, like why does our agent need memory? And I think it's at a simple level, we've all kind of experienced this probably where you have a really good chat with an agent, like, hey, I'm a Python developer. These are the type of packages I prefer. Like, create some code for me. Great. You start a new session, and the agent's forgotten all of that. It didn't learn anything about you. It doesn't know that you prefer Python and these packages, and you have to explain all of this over again to the agent. And like that's annoying on an individual level, but when you're trying to put some of these like AI applications into production at the enterprise, it's really, really hard to get buy-in for more complex and like mission critical AI applications if even like the basic chatbot has these sorts of problems with lost context, or it's also very wasteful, right? If there's a lot of like retrieval that has to happen to build up these learnings, like we want to be able to persist these in some context store, so they're able to treat this as long-term memory for our agent, right? So that's sort of the basic why. Cool. Well, I think that's kind of all I wanted to say, so I'm going to hand it over to Jack to tell us more about Zep.
Thank you, Will. So Zep, we are a context engineering platform, and we run on knowledge graphs. The reason is because we are aiming to make the knowledge graph the unified context store for AI agents. Let me just show this. So this is how Zep works at a high level. You can ingest any type of text data. So that could be chat messages, it could be documents, it could be JSON. So it can be any form, like structured, unstructured, semi-structured. And we have an ingestion process that creates a knowledge graph from this text data. And it's unified. So like entities are deduplicated. If something's mentioned in a chat message, and it's mentioned in a document, and it's mentioned in the JSON, then there's only one entity for it in the knowledge graph. And same goes for the edges, which represent like relationships between entities. And the knowledge graph is meant as this faithful representation of all of that data, but in the unified form of a knowledge graph. And so once you have this knowledge graph, and you guys have just run the script to actually create a knowledge graph in Zep, but once you have it, Zep offers a number of retrieval and context assembly methods so that you can provide the most relevant context from the knowledge graph to your agent, so your agent can be more accurate, be more reliable, be more personalized, etc. Ultimately to improve performance. Does that make sense? What questions do people have so far, just on that? Yes?
Is the main purpose for the same operator to come back into the same place, or is it to share the context so that a different operator can start from where they're left off?
When you say operator, what do you mean?
Using the agent.
Oh, yes, it can be anything actually, but typically we see like the most common thing would be one knowledge graph corresponds to one end user.
A session or a set of sessions.
It would be a set of sessions. So it would be like, for instance, your ChatGPT account. You have one set of memory within ChatGPT, for example.
Is the graph version in exchange of interaction, or I'll just wait maybe for the next slide?
Oh, no, good question. Keep the questions coming. The graph is not versioned. Yeah. Versioned?
Version.
Yeah.
One interaction, session one, I have this graph, and I add to it where these vertices might be pulled in.
Yeah.
Can I go back to a previous memory?
Well, everything is stored in the knowledge graph, including like the past information, and it's always kept up to date. We're not like keeping the old version of what the knowledge graph used to be, but it's a dynamic knowledge graph, so it constantly updates. Does that answer the question?
Yeah, so it's the latest version is what the memory is retrieved.
Yes. It's always retrieving the currently true information. Yes. What other questions are there? Yes.
Is the deduplication, is it semantic? So you have like somewhat similar kind of topics between multiple documents or data stores? Is it semantically deduplicated or?
Yeah. I believe it's partially semantic, and I think we even have some just old school like NLP techniques to see like the amount of matching between the text strings. But we try not to deduplicate, like over deduplicate. What other questions are there? Yes.
Is Neo4j internally has any training?
Has any what? Sorry.
Like internal like retrieving mechanism that can.
Oh, retrieving mechanism.
Yeah, like I also see the Neo4j has this enchanted like features. So what's the difference with
Yeah. Yeah, I'm actually not super. Will, can you answer that?
Could you say that again?
I also see that Neo4j has its own agentic features. So that's similar with this
Similar with what?
like what's like Neo4j also has its own internal features.
Yeah. So, yeah, that's a good question. So, yes. So the question is like, hey, Neo4j has some like interesting like model and agent integration. Like what's the difference between Zep and Neo4j? I think it's kind of like roughly, I guess what you're trying to get at, right? Yeah. So Neo4j is like a core piece of data infrastructure. Right? Like fundamentally, Neo4j is a database, and so Zep is built on top of like Neo4j, and so think of, I guess, Neo4j as like the data infrastructure, and Zep is the like application on top of that that's handling things like the embedding, the entity extraction, like how do you take the messages and build like a temporal knowledge graph of that. So Zep is handling all of that and just built on top of Neo4j essentially. Yeah.
Does that mean you have to use Neo and the J together, or you can have some different form of vector databases you can use with that?
Yes, hypothetically, but yeah, Zep uses Neo4j as its graph database.
But you can always choose to something else, or it has to be Neo4j.
With Zep's managed service, it's Neo4j. Yeah. Yeah. What other questions are there? Okay.
Sorry, do you have any?
No, go for it.
Do you still use Cypher to query this, or is there some other ORM on top of it?
I think there is some Cypher, yes.
Query Zep
You-
Cypher, because it's built on Neo4j, or is there some other?
We don't expose any Cypher through Zep, but I believe there is some Cypher used within Graffiti. Graffiti, by the way, is Zep's open source project. We have 20,000 stars. It's a pretty popular project, and it's generally just a temporal graph builder. And Zep is built on top of that open source project, Graffiti. Yeah. What other questions are there? I keep them coming. Like, this is all for you guys.
The word temporal is
Yeah.
used twice.
Oh yeah.
Obviously, it has to do with time, but
Yeah.
and it's built up over the interactions you have with an agent.
Yes.
But are there events that can come from non-interactions with the agent? For instance, news
Oh, yeah.
feeds or
Oh, yeah.
other things that can add to that graph?
Yes. So first, I didn't explain temporal very well, so I'll just explain that, and then I'll also talk about what you just said. So it's a unified, dynamic, long-term context store. We already kind of touched on the unified. Different pieces of data go in. We have a deduplication process. It becomes unified in the knowledge graph, but it's also dynamic. So you stream in data, and we actually invalidate facts that are no longer true. So for example, if at first you say your favorite coding agent is Claude Code, and then later you say your favorite coding agent is Codex or whatever, then the Claude, user's favorite coding agent is Claude Code, that fact becomes invalidated on the graph. And it's the facts are stored on the edges, by the way, within the graph. It becomes invalidated. We don't delete it. We just mark it as invalid. And then there's a new fact that's, the user's favorite agent is Codex, and that one is marked as valid. So that's part of what makes it like a dynamic temporal knowledge graph, is that it maintains like a history sort of the state So I guess, your versioning question earlier, like to an extent, yes, it does maintain a history. Yeah, and then regarding the other thing you said, yes, you can send literally any kind of text data to Zep to create the knowledge graph. So it could be, as an example, if you have your web application and there's an agent in it, then you would send your chat messages to Zep. But you could also send user interaction events with your application. So maybe the user clicks a certain thing, or they do something that expresses in some implicit way their preferences, or something they might be struggling with. You can send that as an event to Zep, and it will record it, and it will make sense of that along with the chat messages. Does that make sense? Does that answer the question? Okay, cool. What other questions are there? We should definitely get the questions out of the way, because then other things will be confusing if we don't. Did you have a question? Yeah.
I have some questions. I'm not sure if I understand correctly. Is the Neo4j just the database backend for the Zep?
Neo4j is the graph database.
This graph database, is it only used by Zep if we write some application, do they directly talk to Zep, or do we access the Neo4j using something?
If you, did you,
I mean, in Neo4j there's node, edge, and the relationship, right? And is this only used by Zep? And, do the application directly create and define those kind of edge and node, or in Zep define those node, edge, and relationship?
So Zep is the application managing that. So
Okay.
so the entity extraction and resolution piece is
So
managed by Zep.
application does not see the node or in graph node or
Through the Zep SDK, which we'll see some examples of when we get to when we look at the code. So we can see what the Zep SDK looks like.
yeah. Ooh, another question.
Yeah, does Zep support any kind of data set visualization? For example, you might have a graph data set, and I upload it to Zep, does it show can I do a visualization of the data set?
Like a visualization of the graph?
Yes, of the graph data.
Yes, it's in the web app. So if you've run the ingestion script from earlier, then you just need to go to, maybe we didn't show it, apologies if we didn't. You just need to click the users tab and then click Marcus Chen as the user you created, and then click view graph. And then you will see a graph like this one. Yeah.
You want me to show that? in Zep?
Oh yeah, sure. Yeah, thank you. Meanwhile, are there any other questions? No other questions? Okay, cool. Oh shoot.
My fingers are all wet.
Oh yeah. So this is what it looks like in Zep. We're actually planning to improve this visualization soon. But
Can we see the temporal aspect here as well?
oh yeah. Oh, that's a great. You clicked a great example. So this is. Will just clicked on an edge in the knowledge graph, and it shows this box of all the basically information associated with the edge. Here's the main thing is the fact. So here it says Marcus Chen is instructed to create a pull request with the title TFT47 add task sharing, whatever. But here the invalid at date, that because the invalid at date is not empty, that means this fact is actually no longer valid. But we still keep it on the graph. Yeah. And there's a valid from and invalid at, so you actually still are keeping basically the date range that the fact was valid within. So you know when it was valid and when it stopped being valid. Yeah. Okay. Okay. Now, this is just kind of, we already talked about a lot of this, actually. So this is just zooming on to the ingestion part of Zep. So you feed in text data, and there's basically a series of LLM calls that occur to extract the entities from the piece of text. And then given the entities, what are the facts that associate the entities? What are the relationships? Now that we've extracted these entities, how should they deduplicate with the existing knowledge graph? And so we have this series of 5 or 6 LLM calls, and ultimately it gives us a new version of the knowledge graph. Yeah, does that make sense? I guess it's pretty straightforward, and we try to keep it, pretty low latency. It takes about 5 seconds for a single message to ingest, which is plenty of time if you're running Zep in a production application, because let's say a user sends a message, then there might be a couple of seconds, and then that gives some time for it to ingest into the knowledge graph, but also the knowledge graph is kind of meant as this long-term store of context. So it's not necessarily supposed to cover the past couple of messages. With that, we recommend using the actual chat history. But beyond the past couple of messages, you use Zep as the long-term store of context. Yeah. So, okay. What questions are there about that? Going once? Going twice? Yeah.
So it's all connected to Marcus, right? Every node is connected. There's no disparate. You have a source over here and a source over here and a source over here. It's just all connected.
Not necessarily. Not necessarily. It depends on how you format the data that goes in. So if you send, we call it an episode. That's what we call a single piece of text data, whether it's a message or a piece of JSON or whatever. We call it an episode. So it just sees the episode and extracts whatever entities are there. So for example, if you want to make sure that, if your user has an interaction with your application and you want to make sure it's actually associated with Marcus, then you need to add an additional field within that JSON that says associated user Marcus or whatever, and then it'll extract Marcus as an entity that's related to this episode, and therefore extract facts related to Marcus and the other information.
Okay, all the edges will relate to Marcus.
No, not necessarily.
Okay, sorry.
No, yeah. Yeah, I mean, unless all your episodes did that, yeah. But it can represent an arbitrary knowledge graph, yeah, yeah. Does that answer the question?
Yeah, I think so.
Okay, cool. What other questions are there? Okay, so that's kind of the ingestion process. I hope you guys understand. And this is what you ran at the beginning. You ingested 100 messages, which were messages between Marcus Chen, the fake developer, and his coding agent. But you also ingested some JSON files, which represented his environment configuration and kind of preferences. Yeah. So the other end of Zep is the context retrieval piece. So once you have the knowledge graph, Zep provides various retrieval and context assembly methods so that you can provide the most relevant from the graph to your agent. So the simplest version of this is we have a method in the Zep SDK that you essentially right before, if you have an incoming user chat message, you then call our SDK method, and it retrieves the most relevant facts and entities from the knowledge graph that are relevant to the user's message, to the user's most recent message. And it creates this context block already, just automatically created for you. Everything's formatted with the most relevant results. So a concrete example would be, if the user is asking, hey, I need you to create a branch for me. then that message would be used as a search query on the knowledge graph, and it would retrieve that user's branch preferences, like their branch naming preferences or something, or anything else that would be related. And then that's, with very low latency, context block is retrieved, and you just have to put that in like the system prompt of the agent before the agent responds. And then the agent's response is, instead of, if you don't have the context block, the agent would say, oh, what should the branch name be or whatever. But with the context block, it already knows what you want. Yeah. Does that make sense? What questions are there about that?
Can you highlight a little bit more on what are the facts, entities, and episodes? Are the messages like entities or episodes?
Yes, great question. So, okay, there we go. Yeah, so we took a deep look at a fact. The facts live on the edges, as we looked at before. Then there's entities, which you can think of, there's a name of the entity, but then there's also a summary. So I hadn't mentioned this yet, but each entity comes, we have a summary that continuously updates about that entity. So probably the most important, and every single entity has a different summary. So like VS Code, Marcus Chen configures VS Code settings, enables, It's just a summary of what information is relevant regarding that entity. Most importantly, probably, is the user summary, because that would contain the most relevant information about the user. And we treat that specially in Zep, which we can get into if we want. So there's facts, which are on the edges, there's entities and their summaries, and then there's episodes. And episodes are just the raw data artifacts that you originally sent. And actually, in the knowledge graph visualization, you can click this button in the top right corner that says Show Episodes, and then you'll actually see all these gray nodes, all these gray entities, which are the episodes. So this one is an assistant message, and it says the endpoint already uses cursor-based pagination with limit. It's some response in the data set. I synthetically generated this data set with an LLM, so I'm not actually too familiar with it. But it's just some conversation that the user's having with his coding agent. Those are my pet peeves, blah, blah, blah. So whenever I guess you may have already noticed if you got into the context engineering contest, but whenever we create that context block, which one is it? Right. Is it the top? Graphs. There we go. Yeah. Whenever we create that context block, it contains facts, entities, and episodes. And in the contest, you'll be able to. Wait, how do I present? I always forget where it is. Slideshow? There we go. Okay. In the contest, you'll be able to basically configure how many facts go in the context block, how many entities go in the context block, how many episodes go in the context block. And you're trying to get the highest accuracy, but there's limits. We're only going to allow you to use a certain amount of tokens, which means that you'll have to deal with the trade-offs. I'm starting to get ahead of myself. Sorry about that. Before we do that, are there any other questions just about how Zep retrieves context from the knowledge graph, what that context is, and how that context is fed to your agent and helps your agent? Are there any questions on that? Yes.
And just a quick question on the summary. Like, how is that generated under the hood? Are you using an LLM?
Yes. Yeah, it's an LLM, and it uses the previous summary plus the new information and makes an updated summary. Yeah. What other questions are there? Yeah.
Can you tell us anything about the retrieval method in crafting a context block? Does it use some combination of, vector search and graph traversal and
Yes.
magic?
Yes, I'm glad you asked that question. I should have touched on that. So whenever we retrieve the most relevant whenever we retrieve the artifacts from the knowledge graph, we use a combination of semantic search. So we're using like the query along with like the node name, the node summary, the edge facts, or the episodes. We're doing semantic search. We're also doing full text search, and we're doing even graph traversal search. Yeah, which is another benefit of the knowledge graph, is this additional form of search. Yeah. What other questions are there? Going once, going twice. Okay. Yeah, so there's the ingestion, there's the retrieval, and yeah, that now we can get into the actual contest and the workshop we're going to get into. So you're only going to have 2,000 characters, and you're only going to have 2 seconds to retrieve the context block. And the maximum accuracy wins, and there are prizes. So yeah, we've already gone over some of this, but basically the data set that you've already ingested, it's just this synthetic scenario of Marcus Chen. He's a senior full stack developer at TaskFlow AI. He's had 100 messages with his coding agent, and there's also some environment configuration data that's in the form of JSON. This has all been ingested to create the knowledge graph. And now the actual evaluation test questions. So I made 3 categories. There's an easy category, a medium category, and a hard category. And the contest is going to be who can get the highest accuracy on the hard category. So I'm excited to see what you guys can do. But basically what differentiates these is the number of needles that are being retrieved. Like as in needles, needles in a haystack. How many different pieces of information are being retrieved? So in the easy category, the test question would be something like, what package manager do I use for Python? And then the answer would only have just a single piece of information for the answer. Medium, what are my database timestamp conventions? And the answer has 3 distinct pieces of information that need to be retrieved from the knowledge graph. And then hard is, you can't see this, but it says hard, is 5 pieces of info. So that's really hard to simultaneously retrieve all of those pieces of info with the query. So yeah, those are the test categories. Are there any questions on that? Kind of straightforward? Okay, cool. And you definitely should go look into the actual test questions and get a sense for what they are. And then there's actually 2 different metrics that we use for evaluating like a context retrieval and assembly solution such as Zep. So on the one hand, you want the context to be complete. You want it to contain the information that was supposed to be retrieved. So if you ask, what are my database conventions, you want the retrieved context block to contain all of the database conventions. So in the hard category, that's going to be 5 distinct pieces of information that need to exist in the context block. And if they're all there, then it counts as complete. That is different from if the agent actually answers the question correctly. So there's kind of 2 evaluations going on when you run the evaluation script that's in the repository. There's we're going, when you run the evaluation script, we're going through all the test cases automatically, and we're retrieving the context block, and we're using the test question itself as the search query on the knowledge graph to create that context block from the episodes, entities, and facts. And then we're using an LLM judge to determine whether that context is complete, whether it contains all the necessary information that it should for that test question. But then we're also actually providing that context block to like an OpenAI LLM and we're having it actually try to answer the question using the context. And then we're comparing its actual answer, given the context and given the question. We're comparing its actual answer to a gold answer. And the gold answer is an answer that contains like all 5 pieces of information. Where the agent demonstrates that it knows all 5 pieces of information it was supposed to remember. And so the test question is only counted as like accurate. It only passes if the agent's response actually like utilizes the context. So you'll often see, or you'll generally see that you can have the context be complete. All the information can be there, but your agent doesn't necessarily use it. Does that make sense? Does that make sense? Okay. What questions are there so far? I just kind of went through all that. Yes?
How do you improve the knowledge graph or the knowledge rack, and then also how you start making the project?
How do you submit how do you submit a solution? Yeah, it's so we'll get to that. It's in the README. Everything should be in the README. How to submit, in case you've already started. And also recommended approaches are in the README of the repository. Yeah. So, what other questions? Yes.
I may have missed this. How do we know, maybe on the Zep web GUI or something, when the import is complete?
Oh yeah. Great question. You know that. Here, I'll show you. Project settings? No, that one. There we go. I got it this time. So if you're here, if you're in the Zep web app and you come to your user, you just click View Episodes. And if you see that the last episode is marked as processed, it's in reverse order. So if you see that this episode is marked as processed, then the whole thing should be complete. And yeah, generally, I don't think we went through this, but on the web app, you can also see all the separate episodes and whether they're processed and what type they are. This is a message type. And here at this end, we got JSON. Yeah. So once this is processed, then you're good to go to run the evaluation.
And is the evaluation timing it as well?
Yeah, yes. It has a bunch of, you mean like timing, how long it takes for things? Yes. When you run the evaluation script.
I guess I can.
Oh, yeah. It's okay. It has a bunch of metrics. It's really cool. We vibe coded it, so it has all sorts of bells and whistles. Yeah. What other questions are there?
What are the main knobs that you can dial for the project?
To get a higher, yeah. Natural question. It's all in the README, or probably like 90%. Maybe there's some additional things, but everything that you should focus on is in the README. The main ones are, you're gonna, wait, I'm gonna go back to the slides actually. Yeah. Oh, yeah. I have a slide for this. That's great. Yeah. So, wait. Actually, I do want to emphasize first. I'm going to get to your question. Don't worry. But I do want to emphasize that there's a difference between the context being complete and the accuracy. Like we have customers all the time that like don't fully appreciate this difference. Because they'll come to us and be like, our agent is like saying this thing, and we're like, but the context, and when we look into it, it turned out the context was complete, but it's just the agent wasn't using it right, and that comes down to their design of the agent and the system prompt, et cetera. Yeah, so does that make sense? Yes? Seems logical? Okay, cool. Yeah, so the challenge for the contest is to get the highest accuracy accuracy, not completeness, accuracy, on the hard category. So this is the hardest. It's going to generally be the lowest percent score. Because even if you have complete context, you don't necessarily, the agent doesn't necessarily use it. So this is generally lower, not always, but this is generally lower than completeness score. So that means part of what you will do is optimizing a system prompt to make sure it uses the context. So that's part of it, but then there's also the optimizing for the completeness. It doesn't matter how good your system prompt is if the context isn't complete. For that, you can basically do whatever you want to customize how the context block is constructed. So you can change the number. The main things I would start out with is to change the number of facts, entities, and episodes. I think it's defaulted to like 5, 5, and 5. But importantly, the script actually cuts off at 2,000 characters, no matter what. So if you put like 20, 20, and 20, it's only going to use like, because if facts come first in the knowledge graph, or sorry, in the context block, then it's actually like you're using 10, 0, 0, or something like that. Do you know what I mean? Because it's just using the first 2,000 characters. So you are trying to keep it tight. So to start off with, I would recommend you can just twiddle with, what's the best combination? Should I do all facts? Should I do all entities? Should I do all episodes? If not, what's the best mixture? And it's interesting because they're different artifacts getting at different kinds of information. Yeah.
I don't even know if this is the right answer because maybe I don't know about latency, but could you run queries in parallel?
Yes. Or wait. So I will say it is already doing some searches in parallel. So it is actually, if you go look into the script that.
I should just look.
Oh no, it's okay. It's a great question. Yes, parallelization is your friend when you care about latency. But it is actually under the hood. It's doing a graph search scoped to episodes only, and in parallel, a graph search scoped to nodes only, and in parallel, scoped to edges only. Yeah.
What is this ontology?
What is the what?
Ontology.
Oh, ontology. Okay, so you saw that in the README? Yeah. Okay, great question. That's actually one of our really interesting features. That's definitely a bit more advanced for the context. I don't recommend starting with that, but basically we have a feature where you can define a custom ontology for the graph, and it affects, so basically you use Pydantic-like classes to define the most important types of entities or the most important types of relationships for the domain. So in this case, this domain is coding agent, right? So we might define environment configuration preference. That's a type of entity or a type of fact. And basically with Zep, you can define these classes, and basically every entity gets classified into a certain type. So instead of, here, let me show you. We're getting into the weeds here.
How many of your customers use a custom ontology?
I would say most, or yeah, a lot. And I mean, it does work without a custom ontology. And so, yeah, I actually totally should have mentioned this. So this is using our default ontology. You can see here, there's these entity types. This pink is the default. It's no classification. But then there's an assistant type, there's location, event, document, object, organization. So this is our default ontology. It just comes out of the box. So as an example, here's a green one. I need to zoom out, that's why. Oh, wait. Okay, I think I zoomed. Sorry, Will. Wait, I had zoomed out on the window, but not the graph, so it got weird. Yeah, maybe should we press escape and just? Yeah, there we go. There we go. Okay, sorry.
Just to watch some time, because we want people to have like an hour to do that.
Oh, okay. Okay. Yeah, we got to get going. Sorry about that, guys. Great questions, though. So yeah, I'll just briefly explain the ontology, and then we can get into the contest, and then as we're going, we can answer more questions as people have them. But yeah, so as an example, here's the user. It is a user entity type, and it's labeled as such. But you can basically define your own types of entities. So here we have a topic. It's one of the defaults. But you could define whatever else you want, and it would create the graph differently. Like the entities extracted would be focused on whatever your ontology is, and then you'd be able to retrieve and filter to only like things of a certain type or of a certain of a certain type. Yeah. Okay. So just getting into the contest now.
Good question. So if you have a wrong ontology and the evaluation be affected.
If you have a wrong ontology, yeah.
If you change the ontology a little bit tailored to the database, then it will give better answer.
Yes. So we have, yes. And that's why that's a more advanced thing to try with this contest. But we, in our internal testing, have seen that using an ontology that's optimized for the domain can significantly improve performance above what Zep would do out of the box. The thing, though, with that is you have to redo ingestion. So if you want to try that for the contest, you might want to try it, or you could try it now, let the ingestion go for 20, 25 minutes, and then try other things while you're waiting. Yeah. Okay, so why don't we just, yes.
Specific note, is it possible to target a previous suggestion while working on while executing, is it possible to target one with evaluation while you are ingesting?
Yes, it should be. It should be. I don't think I included instructions for that actually, but yeah, when you run you might need to look into the script. There's not instructions for it, but you can look into the basically configuration file that's created for different users. Like if you run ingestion for a new user, it'll create a new configuration file for it, and then you need to target that one when you run the evaluation. Something like that. Yeah, I can work with you to make sure that works. But yeah, to get started with the contest, go to this link, which has never been shown before. It's not the same as any other link. The reason you have to go to this link is because there's an OpenAI key that you're going to be able to use. So you have to go to this link. Or, well, you don't have to if you have your own OpenAI key. But go to this link, go to the repo, and just go through the README. All the instructions are there. Lots of your questions are answered there. And I would just go through the quick start and then start going through the recommended approach for improving accuracy and completeness. And there's also submission instructions and there's rules. So for instance, one rule that's important is don't overfit to the data set. Don't just put in your system prompt all the answers to the questions. Just generally, don't do that. Generally, your solution will only be accepted if it's a reasonable thing to do in an actual production coding agent. Imagine you're actually trying to create a context layer for Claude Code or something. Yeah, does that make sense? So, yeah, and there's some other rules. There's also a latency thing. So, generally speaking, if you're just using the Zep graph search, you don't have to worry about latency. It'll be within the 2-second limit. However, if context construction takes more than 2 seconds, it'll just automatically send an empty context block. So, and you'll be able to see the whether that happened for your evaluation run within the evaluation run results file. It'll tell you, was the context truncated because your context was over 2,000 characters? Did it get cut off because it was taking more than 2 seconds to construct the context? Yeah. So.
Should we show what running the eval script looks like?
Oh yeah, absolutely. Yeah. Has everyone gone to this? Everyone gone to that? Okay, because we're gonna hide it now. We'll pull it back up though if needed.
So.
Shoot.
Space. Thank you. Yeah. So my code space went to sleep. That's one of the downsides of using CodeSpace. I went through like running the ingest script earlier, and I showed how we added in the Zep API key. So you'll also need the OpenAI API key now to run the eval script. So if you have your own, paste that in, or in the Google Doc that Jack shared, there's a shared one we can use. And I'm going to run, if I look at the instructions here, right, I've already ran the ingest, and so now I have my OpenAI key, and so now I'm ready to do a UV run Zep evaluate.
Mm-hmm. Yes.
And do you want to explain what's going on here?
So it's just printing out like the questions and the results. You don't generally necessarily need to look at all that. However, at the very end, there's a summary and a lot of important information. So we'll just wait for this. There's.
At the end, looks like it's specifically for the hard ones, which is what we're being graded on, right?
Yes. Yeah, it should be highlighting the hard accuracy category.
That's the percentage that we're.
That's the percentage that you're going to optimize. And your submissions, we will literally just take the highest. Your submission, you're going to put whatever accuracy was your best. Every single run you do, there's a results file created. Like, keep all of those. And then when you submit, you can just you will create a PR, and the title of the PR will contain your highest percent accuracy. And then we'll just see who has the highest percent and make sure you've followed all the rules, and then you'll get prizes for first, second, and third. $150 on the line.
So even if the PR doesn't have the exact code that achieved the score, as long as you have the score somewhere in the runs, it's good?
No, you should have the code that achieved it in the PR. Yeah.
But that's hard. It's generated when you run the tests, right? So it should be in there.
Yeah. You should be to achieve that accuracy. You should. Yeah, so if you achieve a really high accuracy and you want to save that code and then maybe you should maybe you should branch, yeah. And then you can submit your highest one. Yeah, and you could name your branch with the accuracy number to remember, yeah. Okay, so completed. We can see here, we can see completeness and accuracy scores for the easy category. You can see it's a 95% completeness, very high, and 95% accuracy, also very high. So out of the box, Zep works. Medium, it's retrieving 3 needles at once. Completeness, 65%, and accuracy, 55%. This would be higher, by the way, if you allow a larger context. We made this sort of difficult by truncating it. If you get rid of the truncation, then all these numbers go up. And then the hard, we got a 15% completeness and a 15% accuracy. And this is the number you're trying to optimize. Does that make sense?
Hard accuracy.
Hard accuracy, yes. And then if you scroll up within the results, there's a lot of useful information. So here, the character limit is 2,000. How many context blocks were truncated? 60 out of 60. All of them were truncated. The very end of the context block was not seen, ever. Latency limit, 2,000 milliseconds. Timed out, 0. That's great. Zep is very low latency, so it doesn't time out. It's well under 2 seconds. And on average, looks like 741 milliseconds. There's also some network latency included in that. Yeah, and you can see the original size too. So you know that they were all truncated, but they were all also generally about 3,000 characters. Yeah. So that's pretty important to look at. And there's other information, it's not as important. Yeah.
So I just ran the availability, and I'm showing 37. Showing 37 instead of 35. Is that just
Oh yeah, that could, for which one?
when context is complete, answer is correct proportion. Denominator is 37. Yours is 35. Is that?
Oh, wait, where?
Scroll a little bit more.
Scroll up, okay.
Yeah. Right there. When context is complete, yours says 33 and 35. Mine says 35 and 37. Is that just an LM
Is
equation?
that-
Is that?
Oh, that's just, yeah, don't worry about that. Don't worry about that. That's saying out of the 35 times that context was complete, there were 33 times where the agent answered correctly. So that's kind of a score of how good is your agent at actually using the context. Complete but wrong too. Yeah, so shall we get started?
Let's run the raffle.
Oh, let's run the raffle? Okay, yeah, let's do that.
You want to say anything before? Okay.
All right, cool. So I'll kill this thing.